Okay, we will start today's class with a simple derivation, that is electrostatic potential due to a point charge. Okay, so for that, consider a point charge here, Q. This is the source charge. Okay, therefore that is producing the electric field. What is the source charge? That is plus Q. I'm taking. Therefore, it will be having your, that electric field will be in every possible direction. These are all the electric field lines. Okay, already you people we have seen this one. Okay, right. Now what I want is, I want to find out the electric potential due to this point charge. Okay, at a point, let me consider the point here, at this point. Okay, and this is the point is P, and the point is at a distance that is R from the charge. So my interest is this, let this be O. Okay, the point is O. Therefore, OP that is equal to R. Okay, therefore it is OP is equal to R. That is my point of interest is P, where I have to find out the electric potential at P. Okay, right. So, what you know that by definition, what is the electric potential at any point? Yes, the work done in carrying a unit positive charge from infinity to that point without acceleration. Okay, therefore, now what is the, and also what is infinity? Therefore, I am keeping this somewhere, the point that is infinity somewhere. If I draw this one, this is a point of interest somewhere. What is that? That infinity is there. Why the point? It is infinity. It is going. Okay. Therefore, this point is okay somewhere. That is infinity somewhere. Okay. Okay. Therefore, now what I want is, I have to bring a unit positive charge from infinity to P. Okay, so now before that, what I'm going to do is, and also that I can bring, it is path independent. I can bring the unit positive charge from infinity to P. For that, I may choose any direction. I may bring like this. I may bring in this direction. Okay, I may bring straight, radially. Okay, also whatever direction I take the path, it is because you know that electrostatic force is a conservative force, so that it is path independent. It depends only on the initial and the final position. That already we know, because we have proved that this is electrostatic force and electrostatic field is path independent. Okay, right. Therefore, now what I want is, I am going to keep, I take here in the same path. What I am going to do is, I am going to bring the charge from infinity to P in this direction, radial, along, what is that, the radially, what is the inward, that direction I am going to bring. Okay, because that is easy for me. Why to go for curved path and all? Anyhow, it is not going to change the final result. Okay, because why? Because once again, electrostatic force is a conservative force. Electrostatic field is a conservative field, right? Okay, so now here I am taking, in this path, I am taking two more points. Okay, therefore I take 2 points here, A and B. Okay, and my point A is at a distance, what is that you can say, X from O. Okay, O is the point where plus Q is the source, is the source charge is situated. Okay, and what is the distance between A and B? Let it be dx. Let it be dx, right? Now what I want, say I am keeping a unit positive charge at A. Unit positive charge at A. Okay, and I want to move, okay, the unit positive charge, okay, from A to B, okay, through a distance that is dx. Okay, therefore what is the work done? Therefore you can say therefore what is it? You know that here I am going to bring a unit positive charge from A to B, okay, without acceleration, okay. Therefore you can say, therefore you can say the electrostatic force on unit positive charge. What is that? Electrostatic force on unit positive charge is nothing but E itself. Why? You know, electrostatic force per charge. If I keep a test charge, then it will be equal to E, na? Therefore, which means that electrostatic force per unit charge is nothing but E. So, I can write electrostatic force on unit positive charge. Okay. Yes, what is that? Here it is E. Where? At, let me this is at A. When the charge is kept at A. Okay. First, initially I am keeping the charge plus 1 coulomb at A. Therefore, what is the force acting on it? Force acting on a unit positive charge is nothing but the electric field. Therefore, that is E. Okay. Therefore, what is E? E, that is equal to, okay, 1 by 4 pi epsilon naught, okay, Q by, what is the distance? X. Q by x squared. And what is the direction? The direction of E will be in this direction. Because it will be repelled, na? Okay, so it is a straight line, ma. It is a straight line. It is not appearing as straight anyhow. So I am keeping charge at P here. Okay. Therefore, along, what is the direction? Along OA produced. Along OA produced. Okay. Therefore, so this is when I keep a unit positive charge at A, it experiences some force. That is electrostatic force, not, okay, electrostatic force. That is in which direction? It is, what is that? Along, what is that? OA when it is produced. Okay. Now, therefore, if I want to move that unit positive charge from A to B, then how much amount of work has to be done? Therefore, small work done, I can say, because small distance. So, small work done. Okay. What is that? In moving unit positive charge from where to where? From A to B. A to B is given by small work done dW. What is dW? It is nothing but force into F dot dx. It is F is nothing but E now. Why? Force acting on a unit positive charge. Therefore, I think I can take that force as E. Why? Force by unit charge. Hope you are following. There is nothing there. See everything. Now you should understand. We are going step by step. It is F dot dx divided by, what is it? Q naught. Why? Because it is unit positive charge. Therefore, F by Q naught becomes E dot dx. Therefore, that is nothing but E dx. E in which direction? In this direction. But I am moving from A to B. Therefore, what is the angle between E and dx? 180. Therefore, I can take this one as 180. Hope you are following. This is the work done by the electrostatic force. Okay. Therefore, it is equal to cos 180 minus 1. Therefore, minus A dx. This is the small amount of work done, okay, by the electrostatic force in moving a unit positive charge from A to B. Therefore, total work done. What I want? The work done in moving a unit positive charge from infinity to P. P is at a distance what? R. Okay. Therefore, total work done in moving a unit positive charge from where to where? From infinity to the point P. Okay. Is it clear? This is P. This is P. Okay. Therefore, that is given by W. Okay. That is nothing but minus integral E dx. Okay. From where to where? From infinity to P is at a distance. What is it? R from the charge. Okay. Therefore, that is equal to minus infinity to R. Okay. 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught Q by x squared in dx. Okay, therefore that is nothing but integral 1 by q by 4 pi epsilon naught minus q by 4 pi epsilon naught, take out, therefore infinity to r, and it is, what is that, 1 by x squared dx 1 by x squared dx, and that is nothing but, what is that, x power minus 2 of x power minus 1 by minus x power. I think these are not a very already you have seen many times. 1 by x squared मैंने क्या था, x power minus 2 है ना, therefore it is x power minus 1 by minus 1 if you integrate. Therefore I think I can take this one as that is equal to q minus q by 4 pi epsilon naught. Okay, and here it is minus 1 by x on integration, and limit is infinity to r. Okay, therefore now you substitute, minus and minus will become plus. Therefore, what is the work done? Therefore, the work done here is nothing but, what is that, q by 4 pi epsilon naught, apply the upper limit 1 by r, minus apply the lower limit 1 by infinity, that is equal to 0. Therefore, you will be getting this as q by 4 pi epsilon naught r. Q by 4 pi epsilon naught r. And this work done in moving a unit positive charge from infinity to the point P is nothing but potential at that point. Therefore, by definition, okay, this is electrostatic potential where at at P due to charge Q. Okay, that is, therefore you can say V equal to q by 4 pi epsilon naught r. Hope you are following. There is a, I don't want to go to the next page, okay, so that I can complete everything here. Okay, therefore what is that, q v is equal to q by 4 pi epsilon naught r. Okay, right, now we will go to the next page. Okay, now therefore we got as electric potential V, that is equal to q by 4 pi epsilon naught r. Okay, now q will be when q is positive. When q is positive, V is positive. When q is negative, V is negative. Okay, so positive charge produces a positive electrostatic potential, and negative charge produces a negative, what is that, electrostatic potential. Okay, and of course V is a scalar. V here, what is that? V is a scalar. V is a scalar. That is very electrostatic potential is a scalar. Okay, and therefore when, okay, at, okay, let me say at R that is equal to infinity. R is the point concern is at infinity. Therefore, you will be getting Q that is V that is equal to Q by infinity ho jayega na, and that is equal to 0. Therefore, electrostatic potential at infinity is 0. Electrostatic potential is 0 at infinite distance, at infinity from the charge. Okay, therefore, one more very important thing is an electrostatic potential, very important here. Note, electrostatic potential due to a point charge is spherically symmetric. It is spherically symmetric. This word I think we already used. Okay, for spherically symmetric, what do you mean by that? See, if my charge is here, at every distance, the distance is, okay, R, here, R, here, R, here, R, here, R. Okay, so every point which is at the same distance from the charge, therefore, what is that? It will be the electric potential will be the same. I think you are following. Therefore, at every point, the electric potential is the same. Okay, so which means that each and every point which is at the same distance, okay, will have from the charge will have the same electric potential. Therefore, that says that what is the electric potential due to a point charge is spherically symmetric. Okay, now one more very important thing. See, you know that here V is inversely proportional to R, correct? Let me go for some other color. Okay, which color? Okay, right. V, you know that from this V is inversely proportional to R. And what about the electric field intensity due to a point charge? 1 by R squared, correct? 1 by R squared. Okay, therefore now what I'm going to do here is, I'm going to plot a graph, variation of electric potential as well as electric intensity, okay, with the distance from the point charge. The distance from the point, how it varies from the point charge. Okay, now we'll go to the next page. Okay, therefore, now, first one. Okay, now I have variation of, what is that? Variation of potential V and E. Now you know what is the meaning of it. With the distance from point charge. Okay, now see, this is, okay, this is the distance R. And this is not properly, okay. This is electric potential V. I am going to plot both in same, and electric intensity E. Electric intensity E. Okay, now how to plot? You know, just now we have seen V is proportional to 1 by proportional to 1 by R, or V is inversely proportional to R, right? And E is inversely proportional to R squared. Therefore, how can I see? Therefore, first I'll draw for E. Okay, E, let me take a color. This is E, for example. This is for the variation of what is that? Electric field intensity with the R. This is distance is this. Okay, this is okay. And now I want to plot the same how this one varies. Potential varies. Potential varies slowly, no, because it is inversely proportional to 1 by R. Therefore, I'll take from here. Hope you're following the curve. It's visible now. So it is going like that. Yeah, okay. Right? And it is going slowly now. Like that. Okay. So what is this? This is your V. It is not C. Let me draw proper. Okay. Therefore, this is your V, variation of V with respect to distance. Okay, this itself says that there is a rapid decrease variation of E with the R, 1 by R square na, when compared to what is that, V. Okay, so this is the variation. And if you see that this is here Q, my charge here Q, okay, for this is for Q more than 0, positive. Okay, and if Q less than 0, how to do, how to plot? These things are important. Okay, just you can do this. What is that, V or E? This is distance. Distance of what? Distance of the point concerned from the charge. Okay, the R, what is R? R is nothing but the distance from the charge. That is a source, point charge. Okay, therefore, no, this is not. If Q is, I want to draw a plot where Q is negative. Q is negative. Okay, therefore, Q is negative means this is R, and the potential Q is negative means potential will be negative, and E will be negative, correct? Therefore, here E and V. Okay, in this direction, and here is a distance R. Okay, therefore, how same thing here, E, and I have to draw what is it, rapidly. E will change 1 by R square na. Therefore, okay, I want therefore here it will be like this. Okay, but what this is your E, variation of E with this one. But now what I want to draw, V. V means let it be, it goes like that. Hope this is visible. Anyhow, the color combination is not that. No problem. Okay, hope you are following. ऐसे करके it will take some time to come to 0. Okay, this is rapid, but this is your V. Okay, variation of V with respect to this. Hope you are following it. Okay, so this is XY. This is X and Y. This is Y. Okay, now one more thing, because these things you should know. You should see another one. If I want to plot a graph between V and 1 by R, V and 1 by R, V and 1 by R means what is that? V and 1 by R for Q more than 0. Therefore, it will be like this, because it is V is proportional to 1 by R na. V is proportional to 1 by R. And if I want to plot a graph variation of V, okay, with respect to 1 by r, but v is negative. V is negative. Q is less than 0. That is negative. Q is negative. Okay. In that case, what will be the, it is all inversely proportional r, but it will be in this direction. Okay. So this is, what is that? The plot, different plot that you can draw with this. Okay. Now, next one, we'll go to the next topic. Okay. See, potential. Now we are going to see, so far we have seen the potential at a point due to a point charge. Now we are going to see due to group of charges. Okay, therefore potential okay, because see, it is potential due at a point due to group of electric charges. Group of charges. Okay, very simple. Now apply your superposition principle. That's all. Because anyhow V is a scalar. Therefore, there is the direction doll is immaterial. Okay, that is therefore it is very easy. Then this is what is at the point. There are so many charges are there. Q1, Q2, Q3, Q4, Qn number of charges are there, for example. Therefore, and the distance of the point, I am interested in finding out the potential R to P. Therefore, from the charge Q1, the distance is R1. The point is at the distance of R2 from Q2, R3 from Q3, and this is R4 from Q4, like that Qn. Okay, therefore Rn by, what is the distance here? Rn. Distance of Qn is Rn from P. Okay, therefore what is very simple. You have to find out the potential R to P due to Q1 first. Therefore, first potential, okay, potential R to P due to Q1. Let it be V1. What is V1? V1 is equal to 1 by 4 pi epsilon naught Q1 by R1. Okay. Similarly, what is V2? Similarly, V2 is equal to 1 by 4 pi epsilon naught Q2 by R2. Okay, etc. What is Vn? 1 by 4 pi epsilon naught Qn by Vn. Fine. Okay. Therefore, what is the total? Therefore, total potential. Potential means electric potential here. There is no need to, okay? Potential at P due to system of charges. Okay, that is given by V. That is V1 plus V2 plus etc. Vn. Okay, therefore that is nothing but V, that is equal to, you can take what is that, 1 by 4 okay, if I want 1 by Q1, 1 by 4 pi epsilon naught, okay, Q1 by R1 plus 1 by 4 pi epsilon naught Q2 by R2 plus etc. 1 by 4 pi epsilon naught Qn by Rn. Therefore, that is V, that is equal to, if I take 1 by 4 pi epsilon naught out, you will be getting Q1 by R1 plus Q2 by R2 plus etc. Qn by Rn. Okay, and that is nothing but, that is V, that is equal to 1 by 4 pi epsilon naught sigma I, that is equal to 1 to n. Okay, Qi by Ri. Qi by Ri. Therefore, this is the final expression for, what is that? Electric potential at a point due to system of charges. Hope you are following. Okay, so this is about potential, electric potential due to group of charges. Fine. Okay, right. Now that may be V1 may be positive. See here, that depends upon the charge Q1, Q2, Q3, Q4, etc. If some may be positive, some may be negative. Positive means potential is positive. Negative charge is negative means potential will be negative. That you have to implement here. Okay, that you have to use. Whatever charge is positive means potential is positive. Charge is negative means potential is negative. That will be what is that followed here. Now we'll go to one simple problem. Okay, see what is the electrostatic potential at the surface of a gold nucleus, at the surface of a gold nucleus, and diameters of diameter, diameter 13.2 Fermi. Okay, and Z atomic number for gold is 79. I think you are very much aware of this. Rutherford nucleus chemistry would have studied now already, 11th standard, right? Therefore, what is it? V, that is equal to, okay, and what is radius? Radius, that is equal to 13.2 by 2. Diameter is given, therefore it is 6.6 Fermi. That is nothing but Fermi means 6.6 into 10 power minus 15 meter. Correct? Then what is your charge here? What is the charge? Because see, charge, you are asked to find out the what is the electrostatic potential on the surface. Okay, therefore surface of the nucleus, and here the charge here at the, what is the nucleus is, what is that? Ze, na? Total number of charge here is Ze. Therefore, Q, that is equal to Ze. Okay, therefore, what is that? That is equal to, what is Z? Z is 79 into what is the 1.6 in 10 power minus 19 coulomb. So you know what is Q also. Total, what is it? What is the charge of the nucleus? Net charge of the nucleus. Okay, therefore, what is your V? V, that is equal to Q by formula 4 by epsilon naught R. Okay, there is not, the nucleus is considered as a point charge here. Okay, therefore that is equal to 1 by 4 pi epsilon 9 into 10 power 9. Okay, into charge 79 into 1.6 into 10 power minus 19 divided by, what is R here? R is 6.6 into 10 power minus 15. Okay, and if you see, if you solve it, you will get the answer as 1.7 into 10 power 7 volt. 1.7 into 10 power 7 volt. Is it clear? So that is it.